Hey everyone, welcome to the 9th Ship It session. So in this session, we're going to go also do something related to Kubernetes security. We're going to deploy a whole Kubernetes security platform, or at least the minimum one you should have, with one optional component, of course, which is like runtime security. Let me show you more about the setup first. So here, I'm going to switch quickly to share my screen. Let me share this here. Where is it? Okay. Yeah, here it is. So yes, so we're going to we already set up a Kubernetes platform on AWS on a sandbox AWS account for testing for this, for the sake of this demo. So we have two identical Kubernetes cluster. One is the cyan cluster and another one is the orange cluster, and they're both running on EKS. And we installed on both clusters this really cool project called Kubernetes Goat. For people that are not familiar with the Goat apps, these are intentionally vulnerable applications or intentionally vulnerable setups used to train security people and developers on how to secure stuff. So Kubernetes Goat is exactly that, but for Kubernetes. So this is a super vulnerable setup for a Kubernetes setup. So we can populate so these have some workloads that run on a cluster with a lot of vulnerabilities. There are 22 scenarios of different kinds of things that can go wrong within this environment. And we set it up on EKS. And what we're going to do is we're going to set up a minimum viable security platform on our Kubernetes clusters to detect the issues in this cluster, or detect the stuff we found and existing in this Goat project. We will add a link of this project to the video once it's published, so you can see it now, and try to replicate this with yourself. Yeah. So let me first. Yeah. So how vulnerable? Too vulnerable. Too damn vulnerable. Yeah. So if you want me to give you some examples, let me switch this here, so I can show you some examples of what is going on wrong. So there are sensitive keys in code bases, Docker and Docker exploitation, SSRF for Kubernetes world. So this is actually a web application, like a fake web application, with a lot of issues. Container escape to the host file system, Docker CIS benchmark, violations of CIS benchmarks. And yeah, a lot of bad stuff. You can go deeply into this. I think there's a documentation guide with more details on their website, that you can see all the different kinds of bad things in this cluster. Yeah.
Yeah, maybe George, let me share my screen. I have the application installed, so I can show them live.
Okay, cool. Let me switch there. Trying to find the right window. Okay.
So
yeah, here it is.
Can you see my screen?
Yeah, is this the live application or the one on your machine?
It's the one on my machine, but it's gonna be the same. Yeah, so here you can see the scenarios and what to expect and how vulnerable it is. And I'm sure you can find a lot of write-ups online, so you make your Kubernetes cluster more secure. This is for educational purposes only, of course. So yeah.
I actually show you, I found a nice page in their documentation here. So they start up with a basics to learn Kubernetes. So if you're a security engineer trying to get into Kubernetes security, this is a great starting point. So here it explains all the Kubernetes components, what's going on, and a lot of details on how Kubernetes works and additional links to tutorials, and then goes through the WASP Kubernetes top 10 stuff, or the equivalent of the application top 10, but for Kubernetes. And all the scenarios inside this explain details of what's going on and what's wrong. So this is super valuable for DevOps engineers, security engineers, and developers. As you can see here, I think they mentioned the personas here at the side. So it's super valuable for people working or trying to learn more about Kubernetes security. And this is a perfect example to use when we're trying to deploy a Kubernetes security platform using agents. So we're going to follow the new format that we've been we adapted last Ship It session, which is we're going to do the exact same thing with multiple agents, and this time we're going to use Stackpack and Claude Code with two from the Stackpack engineers. So we have with us today, so Noor is our champion DevRel. was going to be using Stackpack on the Cyan Kubernetes cluster, and Mustafa is our like a very senior member of technical staff is going to use Claude Code on the Orange environment on our EKS cluster. And both of them are going to run this prompt. So let me share with you the sample prompt they will run to try and make this as fair as possible. Yeah, I'm trying to find the private chat. Where's the private chat? Yeah, here it is. Yeah, so this is an example.
I sent it. Yeah.
Okay, amazing. Yeah, thanks, Noor. Yeah, so this is an example. So the prompt says like install and configure Kyverno, kube-bench, and Falco with Helm on my Cyan EKS cluster to detect any Kubernetes security issues and write a report with kube-bench for the CIS benchmark. So there's a lot of moving parts here. So for you who don't know, like I used to be a security engineer full time, and I used to build this stuff over and over again. There are multiple solutions you can use together. A lot of them are open source to build a security platform for your Kubernetes environment. This ranges from stuff like Kyverno, which is like at once actually you find this on my GitHub account. Like I did a comprehensive comparison between all the policies of misconfiguration checks in Kubernetes, which includes Kyverno, OPA Gatekeeper, and a bunch of other things that can be used to check for misconfigurations, but at the same time, they can act as admission webhooks to Kubernetes. So they can block like proactively resources that are not compliant with their policies from being applied to the cluster. And Kyverno actually has the most complete set of policies that you can use out of the box, mainly because Kyverno's policies are in YAML and everyone can write YAML. So it's very easy for people to contribute. So they have the most complete set. So Kyverno can operate in multiple mode. It can operate in detection mode. Actually, like we can Google this together, so I can show you how, like I can give you a quick walkthrough of this stack.
Yeah, maybe show us your GitHub repo.
Yeah, so let me find this here. Yeah, so this is Kyverno. Yeah, it's a policies code platform where you can like write YAML policies and then apply it, like get reports passively, which is what's going on wrong. But you can also proactively prevent stuff from being created in the cluster. I can try show you my repository. Yeah, so misconfigured. I think it's a bit outdated now. Like it's last update was last year, and you can see here like in version 1, I pinned the date and the commit where I checked the policies and checked Terrascan, kubesec, OPA Gatekeeper, Kyverno, Trivi, and yeah, I didn't get to finish Chekhov yet. Or I did. No, I didn't get to finish Chekhov yet. And like these are all like the policies I reviewed. So I reviewed these in 2022. So LLMs were not a thing back then. So these analysis was done manually, every single policy manually, like categorizing them and like grouping them in the same kind of like taxonomy. Like, so this is a taxonomy of possible Kubernetes defects. And this was hand created in this table. So see like there are tons of them across different things, and like different policy engines have different conventions for different things. So for example, some of them considered, okay, you should have a container ID, a user ID that is less than 1,000, but others would say less than 3,000, but others would say less than 10,000. So there are variations between the policies for different conventions, but they all try to protect you from the same thing, which is having very low user IDs and group IDs. You would see like these variations between them. So it was a bit tough to create this, but like, like all these policies were hand created to mix them. And then we did like some analysis on grouping misconfigurations by resource type, and you see some like the resource trying to be configured, and yeah, the issues there, and some categorization. So like this was an attempt to create a taxonomy of all the misconfigurations that can happen in Kubernetes. As you can see, like it's huge. Yeah. And V2 was supposed to map these items to CVE formula and using like a risk rating, like a CVE-like formula. But yeah, this was 3 years ago. I mean, I'm definitely sure these policies evolved a lot since then. And it would be much easier to perform this analysis now, like using Claude or like ChatGPT. But yeah, so Kyverno has these policies that you can write. It runs as an operator inside the cluster and detects passively stuff that violate the policies, or even prevents them from being created, because this admission webhook is sort of like the authorization check that Kubernetes does before it persists any of the like of the objects you're creating on the side, like inside the Kubernetes cluster. What was also the other stuff? So we also have kube-bench. Okay, so let me get kube-bench here. I'm just giving you an overview quickly of what we will be installing and what is it about. Okay, so kube-bench is great for checking specific checklists like the CIS benchmark or like specific compliance requirements. But the CIS is super important because like a lot of regulatory bodies and like a lot of customers ask for the CIS benchmark to pass. And the CIS benchmark is made up of a lot of things inside Kubernetes and a lot of things outside Kubernetes. So like how your EKS, AKS, or GKE setup is being set on the cloud side as well. But for Kubernetes, mostly like we're checking stuff inside the cluster. And yeah, it's basically a huge checklist of things you should make sure to check or perform. And you'd see a lot of overlap between the things enforced by the CIS benchmark or like the things on this checklist and a lot of the policies installed by Kyverno. But yeah, for here it's more like a checklist, but Kyverno is more like the actual operator that enforces these things. Okay, so one last thing, which is like the last part, which is the most mature thing you would do when you're deploying like a Kubernetes security platform, which is runtime security monitoring. So this, I think, like I'm not aware of something other than Falco that does that. I think maybe Datadog, but like I'm looking for open source solutions. Like open source solutions, I'm not aware of like something other than Falco that did that. But again, like I might be a bit out of date and there might be other solutions available now. So what Falco does is that like initially it used to have like a daemon, but now apparently they use eBPFs or like standard Berkeley packet filters to intercept all the system calls going through out of the containers you're running. So Falco intercepts all the system calls, all the networking stuff, all like everything, and then applies some matching rules on top of these like system calls to generate alerts, which is incredible. Like this is super noisy by default because like applications, they generate thousands of system calls per second or minute, like depending on like how many stuff you have running on the cluster. So this is super noisy, and like the rules require a lot of fine tuning and the alerts require a lot of filtering. So unless you have a security operations team or maybe some AI agents to go through these alerts and filter and prioritize them, it will be super hard to adopt Falco if you're a smaller team or you don't have a dedicated security team. I mean, yeah, again, unless you have an AI agent to help you go through this stuff. Yeah, so yeah, this is the basic setup that we will be using today, or like at least our competitors will be using, Noor and Mustafa. And yeah, if you guys are ready, please let me know. So you have the prompt we're going to use to standardize thing. So Noor is going to use the Cyan cluster. So Noor's prompt will be install and configure Kyverno, kube-bench, and Falco with Helm on my Cyan EKS cluster to detect Kubernetes security issues. But Mustafa is going to use the same exact prompt, but instead of Cyan, is going to use the orange environment. So they will be both working on different environments. And yeah, the orange one is for Claude and Cyan is for Stackpack for obvious reasons. Okay, cool. So I'll be keep switching back and forth between their terminals as we start. So yeah, guys, are you ready? 5, 4, 3, 2, 1. Yeah, if you can connect already, like with C. Yeah, I think Mustafa started, right?
Oh yeah, okay. My screen is there, right?
Yes, we can see your screen.
Okay.
So like
I started too.
Yeah, hit enter. If you can zoom in a bit, that would be more visible to us, Mustafa. Yeah. Okay, great. Yeah, just hit enter and start. Okay, so this might take a while. So please, if you have any questions about security, about like agents, about anything, just tell us. So Artemis saying we'll be happy for Stackpack to outperform Claude Code. Yeah, thank you. So the goal here, if this is your first ship it, what we do here is we test stuff live without any preparation. So we just prepare the environment, but we don't run these tests before we actually like run the ship it session. So the goal here is this to be raw and realistic with minimum preparation. So we're like we go to these sessions, we're not even sure how like each agent would perform, but we're testing this stuff with people live. So we can learn how to improve Stackpack, and you would learn where the limitations of the agents are and how to use them better. Yeah, so please ask away like any questions you have about like Kubernetes security or like building agents, because that's the goal here. Like we're trying to learn together.
You have any ideas for future sessions? That would be awesome.
Yes, that would be great. Yeah, so let's see what Noor is doing here. Yeah, so this is Noor is in Stackpack. Stackpack is now installing Helm, using Helm to install Kyverno in the Kyverno namespace and Falco as well. Okay, cool. Where's Mustafa? Yeah. Seems Claude Code is installing Kyverno too now. Yeah, Artemis is saying that he would love to see Stackpack using less tokens. So okay, so there's a slight bit like of a difference between how Stackpack and Claude Code billing works. So Claude Code billing uses tokens, but Stackpack uses successful requests. So if you made like a Claude Code request and Claude hallucinates or like break tool calling or something, you wouldn't pay for the request. But we charge per request because we found that it's easier for people, and we don't charge for like failed requests in case like the Claude hallucinates. And both of them actually use Claude 4 behind the scenes, so they're using the same base model, but the tools, the configuration, the context engineering is different. Okay, B, the platform is asking a question. So yeah, the Stackpack supports sub agents for parallel processing on complex tasks as Claude Code. So parallel processing is a bit different. So the main reason people are building sub agents. So we have like to answer this question first. Like we have an open PR on supporting sub agents, but the way we build sub agents is pretty different from Claude Code. So the main reason people build sub agents initially was for context engineering. So to manage your context, because if you have like a big research task or like a big reading task, like that would span multiple like a big code base, you wouldn't want to retain all that in the context and run out of context quickly and then be forced to compact your context history. We found that like compaction like negatively affects the performance on longer running operations tasks, and that's what Stackpack is optimized for. So instead of needing like we didn't need sub agents initially because we didn't need compacting as much, because you can run Stackpack for like a 200 message session and it would throw away the useless parts of the context or the history without needing to compact the history or summarize it. So this kept Stackpack running very long. So on the other hand, like parallel processing is pretty different. So people, when they build sub agents, they do that to compact context first. And parallelization is not like very, like it's not effectively parallelization because, for example, like if you spawn sub agents, you'd have to wait for the agents to finish to be able to do something else. We found this like feature specifically is super important in operations. Like you need to spawn, for example, like when I was creating this sandbox environment today, I wanted to create two identical clusters and apply them with Terraform apply in parallel without blocking my main thread. And this is something I can do in Stackpack because we have like async background tasks. You can start spawn threads that would do something with true parallelism on different like CPU cores at the same time without blocking the main thread. And if you're starting sub agents with Claude Code, it would actually block until these sub agents are done and then continue working. So the PR we made, or like the open PR on Stackpack, because like Stackpack is actually like the agent is open source, you would see it supports sub agents with parallel execution. So you can actually spin off 3 or 4 sub agents, have them run in the background with a task manager, and the main thread would be free to do things and then check up on these sub agents in the background. Yeah, so I hope this answers your question. So we didn't need sub agents initially for context management, but we needed them for tasks that require exploring cloud accounts or applying stuff in parallel. So we implemented first asynchronous task execution, so you can run multiple commands in the background and check on them without blocking the main thread. And there's an open PR that's going to be merged soon, which supports multiple agents that execute in parallel without blocking the main thread. So it's kind of like the best of both worlds, asynchronous background tasks and sub agents at the same time. Yeah, I think my answer was too long, but I hope like, yeah, I love digging into the details. So if you have any questions about like agent architectures and trade-offs, we'd love to discuss that more, as you know by now. Yeah. Okay, so until more questions come in, what's going on? So what's Claude doing? Yeah, Claude is facing an error. I'm not sure what is the error because I can't see. Text is pretty small. But let's check up on Noor.
Yeah, Stackpack is configuring Kyverno, like the security policies. There was a bug with the EKS version, but it fixed it.
Okay, so I caught Stackpack like researching documentation online and then doing something to fix something, but like I'm not sure what it is. Yeah. Okay, so we have another question. So Artemis is asking, what do you think about GitHub being under Microsoft supervision instead of being a standalone company and open source repository open? I don't know. Like this is a very political question. Like please, yeah, I would be happy to discuss anything agent related and security related, but like yeah, this has nothing to do with like agents and security nor yeah coding agents. But yeah, like if you want my personal opinion, I think it's fine. Like GitHub was already under Microsoft supervision, maybe like less tightly controlled, but like it was already there. And actually, Microsoft have been doing great for open source lately. Like, I mean, Microsoft is the company like behind TypeScript.
They are making an agent
yeah,
for reverse engineering.
Yeah, this is incredible. Like reverse engineering is super hard. I tried learning reverse engineering once. It's tough. Yeah, so B, the platform, is asking. So what I know is that Stackpack is a wrapper above Claude Code. So how did you manage to create your parallel processing? Stackpack is not a wrapper behind Claude Code. Stackpack is an agent built from scratch, and it was actually launched or released before Claude Code. So if you check the repo history, you would see like we've been pushing this. Like we released the first version. It was not like using a TUI back in January. We developed the TUI after getting inspired by Claude Code, but like the agent has been out there already. So it's a complete implementation from scratch of an agent that supports MCP in Rust. And Claude Code itself is not written in Rust. So like it's a different tech stack. It's written like completely from the ground up for operations or to be optimized for operations and security stuff. So be saying I got that kind of sub agents, but not quite similar arch-wise. Yes, exactly. That's why it's pretty different because like different people implemented it and like they're built for different goals. So no, it's not using Claude Code internally. You see, like the interface is very different. So for example, like what you see now when you're running the command, it's streaming the tool call results in the UI. So this is something that is not there yet on Claude Code. It doesn't stream the tool result output. And like the reason we did that is because when you're building a Docker container running Terraform apply, you want to see the progress. Like you don't want to wait 30 minutes or 40 minutes until you see a result. And that's very DevOps specific.
So Stackpack finished and it generated the report and it's asking me if I want to fix it. If I want to fix the vulnerabilities.
Can you read the stuff? Like what did the report catch? And is that everything that wasn't like the GOAT setup?
I don't know, let's see.
What is it doing now? It wrote it down. Okay.
Yeah.
Mine is securing. I don't know what is it securing, but yeah.
Yeah. So let's check quickly on Claude Code before going back. So what is Claude Code doing?
Yeah, it's installing and configuring Falco, but it's still secure. I don't know what it's updating to dos, so it is staying there. I don't know what it's doing. Okay.
Yeah, I think something like really cool with the Claude Code interface is like they come up with like AI generated variable like verbs, which keeps you entertained, like securing now. Like it's very context specific, which is cool.
Yeah.
Yeah, B is asking, how can I try the parallel processing on Stackpack? So one thing you can do, you can ask it like to start something in the background or like run it as a sync command. So if you spin up Stackpack and you ask it, okay, start a server, like a Python server in the background, or like start port forwarding in the background and then ping the agent or something. That's how you would get it to run something. So you have to use a keyword like run in the background or run it asynchronously or something, or like force it to try doing something that it would need to start something in the background and then like run it. One thing that I bumped into, a task where like I needed to monitor, like we did this on one ship at once, like I think a couple of weeks back. We started monitoring like the metrics on an ECS task, and then in parallel started like generating workload to see how the metrics change over time. So this is like we forced it into running a background task this way. Yeah, Tuan, I hope I'm saying your name, I'm pronouncing your name right. So Tuan is saying, can we tweak guardrails for the agent? And also, does this support instant rollbacks on the previous state before the agent performed a specific task? So yeah, we have a different kind of guardrails, something we called warden. So the first line of defense is just like approving commands, but the second line of defense is called warden. And warden actually runs Stackpack within Sandbox and prevents it from doing destructive operations. So you can run Stackpack asynchronously on your AWS account or like doing something on Kubernetes. And if it's running with Warden policies enabled, it will not be able to do anything destructive. So it'll be able to get resources, read resources using the AWS CLI, Terraform, or like kubectl, but it wouldn't be able to destroy anything or make changes to anything. And this is a catch-all kind of guardrail to prevent it from making destructive API operations. So it doesn't care about which tool the agent is using. It would still prevent the destructive operation nevertheless. So we found this much better, much more reliable in the ops context, at least more than whitelisting and blacklisting commands. And Tuan is also asking, following up, does it support instant rollbacks to previous state before the agent performed a specific task? So Stackpack can roll back to a specific checkpoint and then start again. So like the checkpoint system, or the session in Stackpack is more like a tree. You can like go back to and start executing the agent from a specific checkpoint and then branching out in a tree. But this is all about like the state of the agent itself, not the external world. So if you want to roll back a file change it made, you'd have to ask it to roll it back. We currently don't support like rolling back changes. If you have Git, that would work, but there's also like an RFC we're working on to do that, like to be able to support rolling back file system changes, even if you don't have Git installed. Yeah, thanks to one. Okay, so where are we with both agents?
And Stackpack finished, and I asked it to explain the report. So it's we deployed Kyverno, and we have 17 active security policies with restricted pod security standards. And Falco runtime is working using ABPF. And kube-bench, like it completed the assessment, and we only passed with 1.7%. And like it is asking me if I want to fix the high priority issues like authentication, authorization, misconfiguration. So there are like, I think I should ask it to fix it. What do you think?
Okay, I think like this answers the question of how vulnerable Goat is. Like, I mean, yeah, we only passed like
it
1
is
out of
designed
59.
to be vulnerable, yeah.
Yeah, we passed only 1.7% of the CIS benchmark. Yeah, I think you should actually start fixing stuff. So yeah, maybe prompt it to start fixing things. While we check what Claude Code is doing. I saw Claude Code like already like outputted the results, right? Mustafa.
Yeah, it did.
Yeah, okay, amazing. So it
it found like it installed Kyverno, kube-bench, and then the result that came back with CIS Benchmark was the one check passed. 17 check failed. 41
amazing.
checks.
Yeah, so we got the same result. Like it also only passed like a single check.
Yeah, but yours was like more colorful, better view, but yeah, still, it's good.
Okay, amazing. Let's ask it to fix the issues, please. Yeah.
If you fix these issues.
Yeah, because that went really quickly. Like, yeah. So, and if you have any questions about like the setup we set up and like anything about Kubernetes security or agents.
Maybe, George, you can explain from the image why did the engineers invented DevSecOps?
Yeah, again, DevSecOps. Okay, yeah. So this is a very cool illustration we put here, which is like the literal bottleneck, which is security. Like security, yeah, that's the hard thing about security. Like if you're a security engineer, developers rarely listen to you unless like the business forces them to, because a customer asked for a compliance framework to be met or something. Because like it usually slows things down. So by default, a secure system is a system that is static and doesn't change. But like since we want to keep pushing stuff, especially in product companies, like we want to keep releasing stuff, we want to keep adding features. Yeah, so the counterproductive thing would be to pause everything because it's secure if it's not changing, if we know how everything works. But that's what we're trying to do with DevSecOps, is like remove this bottleneck, allow people to move with the same speed, keep shipping without slowing them down, but at the same time doing the right thing in terms of security. And that's what you see like these Kubernetes operators are doing. So Kyverno, kube-bench, or Falco, they're continuously running in the background, like looking into security issues as they're working, or even preventing them proactively. without you having to worry about that, like, or being like very conscious, because as you're developing or scanning stuff, you would see the bad things you're doing without having to think about it deeply, at least from a developer's perspective. So Artem is asking a question. So Artem is asking, can we compare the issues found by both agents to see whether if any agent caught an issue the other didn't? So I think both of them caught the same issues. So both of them, they found on, because they didn't do the scanning themselves. So we told them which tools to use, and the tools did the scanning. And what Stackpack or Claude Code are doing, or the agents, they set up the tools and then they can help you prioritize. But yeah, that, I think like it wouldn't be reliable to use the agent to find the security issues unless it's something very high level or like on a business logic kind of level. Otherwise, static analysis tools and policy as code tools like Kyverno are way better because they are deterministic. Like every single time you run the scanning policy rules, you will get the same results. But then the agent will help you fix this stuff because no static analysis tool can help you automatically remediate the issue or prioritize issues based on your like business requirements. That's why like you get the same results, which is a good thing, like that they both get the same results. You want this kind of reliability when you're doing security scanning. Yeah, so Claude Code is patching stuff. I think here it's an issue with like mounting service tokens by default. And what is Stakpak doing? Also fixing stuff.
Disabling the autonomous service account.
Okay, amazing. The same thing.
Yeah. Can we have a cron job that runs this automatically, or what do they do?
Do you mean the patching?
Yeah, and like compliance reporting. Like,
I think there is an operator that can run the compliance check or generate the report live. As soon as something changes, you get a new report. That's the beauty of Kubernetes operators. But like the patching, I wouldn't do that. Like if it was me, I wouldn't do it automatically. I would definitely like ask an agent to create a PR if I'm using infrastructure as code and then review it before merging because it might break something. Yeah, Tuan has another question. So are we able to configure the LLM used by the agent since LLM and SLM improve and get lighter over time? So yeah, we had a lot of internal technical discussions about that. At the moment, like Claude Code, like the LLM is fixed. Like we optimize. Like it takes months to optimize a system for a specific LLM. So it took us a while, for example, to upgrade from 3.7 to 4 because you had to refine the prompt. And if you take this agent, replace Claude 4 with like GPT-5, you will get like a terrible performance because the system prompt is not optimized for GPT-5. You need to auto-optimize it. So what we did internally is to be able to test like these new models. We're building a prompt optimization, auto-optimization pipeline, which takes a new model and like a random starting point of a prompt, and then tries iterating on the prompt to refine it. So then the new model can be used. So you would see like it like if you replace the model of the agent randomly with different LLMs or SLMs, you wouldn't get a like the best performance out of every single model because you need to optimize the system prompt and the whole pipeline for this specific model for it to work well. That's why like Claude Code works great with Claude 4. But if you try to use a proxy and use GPT-5, for example, within Claude Code, or like use open code with it, like random with GPT-5 instead of Claude 4, you get like a much worse performance. What you're saying about SLMs improving is yes. So we're doing a lot of experiments to allow people to run the Stackpack agent locally on their laptops. I mean, if you have enough RAM to host like a 32 billion parameter model quantized locally, this requires a lot of fine tuning and distilling to make the smaller model as smart as Claude. Then it would work with the Claude prompt. So this is something we're experimenting, but it's not ready now.
So Stackpack finished. It reduced the attack surface and implemented the principle of least privilege and the token security and like other stuff. And now it's recommending that we switch to the enforce mode but I don't know what is that, so I will ask it.
Okay, cool. So yeah, I know like the Kubernetes, like Kyverno enforce mode prevents any manifests or like any Kubernetes objects that are not compliant with the Kyverno policies from being applied. Because now it's only in check mode, but like here, let's see what it says.
I think I'm done.
Okay, cool. So Claude Code is also done. Amazing. So can we both like run the benchmark again after like the fixes to make sure like we pass more stuff?
Yeah, it ran the benchmark again to our improvements. So basically,
So what results did we get? Like, what's the compliance rate now?
Policies. Now, sounds good.
So Tuan is asking if Stackpack provides an audit trail log for compliance. Yes, we definitely do. So Noor's session, like or everything Noor ran, would be available through the UI, so you can check the session history in the future. We do that for two reasons. The first one is for audit and like audit trails, so you can see the sessions and share it with other people on your team in the future. So you can see like how you did something. So it records everything you're doing within the session. The other reason is for memory extraction, because you can take this like session and then extract memories from this session. So the agents, like these memories are shared between users. So people in your team would be able, like the agents running, like the agents you're running in the future or other people on the team are running would learn from the sessions you already ran before through these memories. Okay. Can you show us like the session?
Yeah.
Okay. Yeah, that's it. Yeah. So this is basically like the session Noor is running now. So everything.
Every call.
Okay, cool. Yeah, let's check the compliance rate now. So Mustafa, did you get the report yet?
Not yet, still working.
Okay, cool. Noor, did you get the report?
Yeah, I'm trying to look for the percentage.
Yeah, only one still passes? Okay, so Stackpack is saying why no immediate improvement? Because most failing checks are related to EKS managed control plane. So configurations of the EKS control plane itself.
Run enforcement.
Worker node file permissions, which requires node level access, and kubectl authentication settings, which is EKS managed. Interesting. Yeah, remember when I said like the CIS benchmark covers more stuff about like the Kubernetes setup itself, not just like what's inside the cluster, some stuff related to the cloud provider. This is what I meant. Like it checked stuff in the EKS configure, like EKS setup themselves on AWS. Yeah, so Artemis is saying, can I find the Stackpack system prompt file on GitHub repo? Not yet, but yeah, we'll open source the system prompt soon because, as I said, like we're building a system that would automatically keep optimizing the prompt based on user feedback every week. So the system prompt is not actually going to be IP anymore. Like it wouldn't matter. But like another cool feature we just launched last week is actually like you can override the system prompt. So if you're calling the Stackpack API, you can provide a system prompt, and if you're using the agent, you can override the system prompt with a flag that's called, I think, -- system prompt file to experiment with different things. So we're technically not hiding the system prompt, but it's not defined in code. It's defined in like our observability system, so we can iterate and A/B test the system prompt actively. We keep changing it and updating it every week, and yeah, pretty soon we wouldn't be even doing that manually. Like the auto optimization pipeline would be doing that on our behalf, because LLMs are much better than humans at like refining system prompts or at prompt engineering. Okay, let's check up on Claude Code.
I run the enforce mode.
You're enabling enforce mode. Okay.
Yeah, I did. Now
that's very brave of you. Yeah, that's very brave of you. Like we initially, like when I used to work like as a security engineer on the platform team, we were scared of doing that because like developers would like, yeah, if something breaks, developers would like kill us or something. I'm curious how much this costs on Claude Code after we're done. Like, yeah.
Like how many tokens?
How many dollars? So I think Claude says that Kyverno policies, we now have 231 checks passing and 192 checks failing on Kyverno, not the CIS benchmark. I think we should be checking both. Like we should be checking after the patching. Yeah, I think Claude is also saying that the CIS benchmark still only one passes, even after the fixes. But we need to check also what Kyverno like policies are like, or the results for like applying the Kyverno checks. Yeah, so
yeah, I was gonna say Stakpak is saying that the CIS compliance still needs work.
Yeah, okay. I think on the EKS side of things, right? It already said that. Like I read that out loud.
Yeah.
So what did it fix? Like can you show us the coverage of the Kyverno policy? Like how many policies Kyverno deployed that are actually passing? Because now we know like the CIS requires EKS changes.
Yeah, let me do that.
So let's check Stackpack. So Amjad is asking, yeah, guys, please excuse me if I'm not able to pronounce any of your usernames. Is this all open source? Basically, you give the MCP config, and how do we get the key or token to connect to it? So the agent itself is open source. Like I can show you the repository here. You need an API key because like you have to run get access to an LLM somewhere. So let me add this to stage and then show you Stackpack. So Stackpack agent. Yeah, so you can see here like the agent itself is open source built in Rust, which includes like the client and the MCP tools. So all the tools like that do like the do dynamic secret redaction, the streaming, all this stuff is open source. But like to be able to use this, you need an LLM. You can use this as a standalone MCP server to get like the security hardened tools. But you need the API key to be able to access the LLM. So you can access Claude through Stackpack API to do the inference side of things. So Tuan is asking, does the agent come with token usage and cost analysis inbuilt? So as I said, like we bill per request, not per token. So for every successful request you build, and like the paid tiers have like, for example, like the free tier has 100 requests for free, and Noor, can you show us like how many requests you consumed so far on like the Stackpack session? Yeah, just here, just refresh the page and like show us the API request at the top. Okay, so
it's
this
83.
is 83 or 33?
83.
83. Okay. Yeah. So everything we did today took 83 token sessions, 83 requests, regardless of the sessions used. So all of this would pass within like the free tier. But like, for example, like we have the hacker tier, which gives you 200 requests, and we have the builder tier, which gives you like 1,000 requests for like $49. That's how like billing works. And you can see like how many requests you used. So it's not on the token level. So I'm just saying which specific compliances is run the benchmark against. I think only the CIS benchmark. So Kyverno is a mix of different things. So the policies or the rules in Kyverno cover a wide array of things, like a lot of things, and not all of them would fit under a compliance framework, but they're all like either generic security best practices or they look for specific CVEs on the side. But like the CIS benchmark is just like the CIS checklist. Noor, do you have something to add?
Here it says, yeah, it says like it ran 17 out of 17 policies for Kyverno, but it's still not passing the CIS benchmark because it's related to EKS and AWS.
So is it enforcing 17 policies, or it's because like it might be checking for a lot of things?
Enforce.
Yeah.
Yeah.
Because I thought Kyverno is actually deployed with a lot more policies.
They can check.
Yeah, please do that. Yeah, so these are the policies. So they're not necessarily covering a specific framework, but they span multiple frameworks. So I'm just also asking, Gotcha, so that's an open source agent. Are you planning on creating an MCP server of it and have a central dashboard on your side where users can log in and see the findings? I don't get that part. Like, what kind of findings? Actually, like Stackpack runs in a CLI. Like you can trigger it from any other agent. It's fine. We tried creating an MCP server over our tools, not the agent itself. And yeah, we partnered with a couple of people like building coding agents like Continue to Dev, so you can access like the Stackpack MCP tools through Continue to Dev. But we found out that like a lot of the optimizations we're doing required us to have like our own implementation. For example, like streaming tool calls or optimizing context management for the agent. So we provide the agent's brain over an OpenAI compatible API, but we built a lot of context engineering stuff in the background to make sure it's able to run like on long running tasks with long horizon, like keep running for like 200 messages without like losing context or like losing focus. So all this stuff required us to create our own OpenAI compatible API to build this kind of things in the background, and also required our own MCP client implementation to support streaming and other stuff like background tasks, which are not easily supported just through an MCP server. So like if you add these features in an MCP server and try to use them through another coding agent, you wouldn't get a lot of the stuff we do, like the asynchronous jobs, for example, or like proper secret. Like you could actually get the proper secret action, but you wouldn't get asynchronous jobs and wouldn't get like command streaming, for example. So I found a lot of limitations in this approach. That's why we decided like to make this like a standalone agent. It also is a single binary that you run, which is something cool we got out of building this as Rust. Is like you can just compile it as a binary. You cross-compile it for multiple platforms and just pull it and use it. You don't need npm to run this stuff. Like you don't need npm to run the agent or any of the MCP tools. They're just like packaged in a single binary. Okay, so what is Claude trying to do?
I'm trying to figure out the said before like 17 failed and 49 warned and one passed. I'm trying to get the same results again to see what passed, warned, and failed again, but it's actually not like it doesn't want to hear what I'm saying. So
okay, let me check on Stackpack here.
Stackpack said we can implement monitoring and alerting using Prometheus, and I said yes.
Okay, so Stackpack is trying to bait you into using more requests and doing more work.
Such an agent.
Yeah. Cool. So yeah, I really hope this was useful to you all folks. I hope you learned a bit about like Kubernetes security if you haven't checked this before, how like all the different operators work and what they do, and learn a bit more about like Claude Code and Stackpack. So I hope this was useful. Please like let me know. We have like almost like 10 minutes left. So yeah, just shoot if you have any questions. Otherwise, I think this was like a really cool session. Like I had a lot of fun. I love the security stuff.
Yeah, but who won, Stackpack or Claude?
I don't know. I think there are no neutral people here. Like we're all part of the Stackpack team, so I think we'd better leave that to the audience since we don't have like impartial judges between us. Yeah, if you think like one agent like won this battle, just like add it as a comment or something. So neither Noor nor Mustafa have a lot of experience in Kubernetes security, so they're all doing this from scratch for the first time, which is really cool. Like, I would love to hear what you guys think. Like, how do you feel as like regular developers securing Kubernetes for the first time?
Yeah, I think it was fun. Like, it's not complicated. I think the tools are helping a lot. I didn't do this without an agent, so I don't know like how hard it would be without an agent. Maybe you can tell us.
I don't agree. Like, it's really scary. Like, doing something like for real, this big scale as Kubernetes, and deploying it without knowing what's really happening, and you're having your fate into the agent's hand is kind of scary for people like me. Okay, I'm sure it's for security people like you. You understand most of it, so it gets there with time. But yeah, for me, since it gets done and everything is happening, that's right. Okay, that's right for me. But knowing what's in between and knowing if it's secure or not, that's something else. Like, I would love to see like an agent that is secure enough to hold my back, like to prevent me from doing something so destructive or something that would harm my infrastructure, and point me to the right direction throughout the way, even though if I like, regardless of what I know about this process, like
I think the technology, like the agents keep improving. Like, we're not completely there yet. Where like without any, like for example here, like we fed it information about which tools we would install exactly. Like, if you're starting from scratch without any security experience, you wouldn't know which tools to use. And that's something like we can test like how the agents do in like in terms of tool discovery and recommendations. But yeah, I mean, installing stuff on your cluster can always have like destructive side effects. So even if you can install this stuff, it doesn't mean like you don't need to review it first before installing it. So having the agent do that for you, that would be great. Yeah, and that's one of the reasons we're building Stackpack. Yeah.
Okay, it got me a new report.
Okay, so Claude created a report.
We had this before, right? So we had one check passed and 17 fail on Warren 41. And then after I did that, which is good, I see a lot of check marks. Okay, and then so the past was 18 to 12 checks, 13% or 20%. Fail.
So what did it fix? Because I thought some of the CIS stuff is like AWS specific. Like what did it fix? I mean, how come the compliance is actually between 15 and 20%? Like, why is it not like a specific figure? That's weird.
Yeah, and it doesn't tell me like what did it fix exactly as names, but I kept trying to ask it, but it doesn't respond to me. Maybe
that's weird. Yeah, it's weird. It didn't come up with like a specific percentage of fixes.
Yeah.
So how do we check that Claude is not hallucinating? Yeah, that's tough. Okay, yeah, but like, I think we're out of time.
Like, this is what I mean. Like, how do I know if it's hallucinating or not? Like, it's exactly what I mean. But still,
yes,
getting results and deploying and doing something that comes up with a result at the end, it's a leap, indeed. Yeah, okay. In the DevOps world, I agree. But yeah, I would like, as I said, like, I would feel more comfortable to know that this agent is shielding me from stuff that I don't know about.
Interesting. I think like, and to answering like Artemis's question earlier about like comparing the results, I think having these deterministic tools running like Kyverno and kube-bench, where you can like run a specific command, get the real report without an LLM being in the middle, this would help you get like the result. So I wouldn't rely on the LLM reporting the result unless it is accompanied by a report generated by the tools themselves. Yeah. Because like if you rely on the LLM to review stuff, it's not like, as a human, like if you ask two humans to review the security of your Kubernetes clusters, they might not come up with the exact same result.
I agree. I guess next time we need a benchmark that we can compare to know if an LLM or agent got the result right, like at least close. So yeah.
Yeah. Okay. Thanks, Noor and Mustafa. It was a pleasure like doing this with you again. And yeah, I hope you all found this like useful. And see you all in the next ship next week. Yeah. Have a nice
Thanks,
one.
guys. Bye.
Bye.
Bye.